Z naught. So what is the distance from here all the way up till here?
A1.
A1, so that will be the link length, which is why we call A1, A as the link length. Okay. Alpha is the, if you look at alpha is the angle between the two z-axis measured along x. So if you're measuring the angle along x, this is the direction of measurement, this is x, right? If I'm measuring along x, what is the angle between the two z-axis? 0, because they are parallel, right? 0. D is measured along zi minus 1. So zi minus 1 is z naught. So distance along z naught till it intersects with x1. Where does it intersect with x1?
A1.
No, you're measuring the distance along this axis, you're not measuring along this. You're already measured along x, right? You're measuring the distance along z naught till it intersects with x1. Where does z naught intersect with x1?
O1.
O1, right, at the origin, right? So this is going to be 0, all right? Same thing here, x2. So you measure along x2 till you go to the previous origin, O1, which is this distance, A2. When you try to measure the angle, alpha is the angle from here. These two are parallel axes, so this is going to be 0. And now you measure the distance along x1 till it intersects with x2. It again meets it at the origin. x2 meets it at the origin. So the distance along this is 0.
I
So-
don't get it.
I'm sorry? You
Can you
didn't?
repeat it all again?
Fine. So first thing is A. A is a distance measured along xi, right? So if I want to measure A1, I'll measure distance along x1. So x1 is measured from here, from this origin, all the way till it intersects with z naught, the previous x. So the distance, this distance is
A1.
A1, okay. Same thing here. You start from this origin, move along x2 till it intersects with the previous z-axis, which is z1. This is A2. All right. Now alpha. Alpha is the angle between the two z-axes. In this case, all the z-axes are parallel to each other. I mean, which might not be the case as we do the next example. But here, this is parallel to this. Parallel axis, the angle is 0. So both the alphas, in this case and in this case, is 0, 0, right? Let's talk about D. You already did the measurements along x. A is measurements along xi, okay? D is measurements along zi minus 1. So in this case, when I'm measuring D1, I'll measure the distance along zi minus 1, which is z naught, okay? The distance along z naught till it intersects with x1. x1 comes and meets z naught at the origin. So there is no distance along this direction, all right? So if you want to have D1 here, the link would be like this. Then you would have a distance here, okay? In this case, it's meeting exactly at the origin, okay? Same thing here, x2 meets exactly at O1. So that's why we have these two as 0, 0. Is that clear? All right. Now, based on this, we will construct a transform here. So we'll call this as A1, and I'll talk about this in the next class. I don't want to confuse starting transforms. Let's be very certain about the DH table, and we'll build another transform called A2. So the total link transform, that means anything that goes from here all the way till here can be represented as 0, 2, which will be equal to A1, A2. Okay. So from this, we'll construct a homogeneous transform, which will be 4 by 4, A1, 4 by 4, which will represent this transform due to this link, and we'll have another transform due to this link represented by A2, and the composite transform will be A1 times A2. Okay, let's try another manipulator for today. Once we completely understand how to do a DH table, we can start doing the putting together transforms. Okay, let's take a example of a cylindrical robot. I want you to set up the axis. Obviously, the axis is, as I said, you can come up with another set of axes which is completely different. The DH table can be different, it's fine. I'm going to give you the reference axis so we all start in the same fashion. this length, let's say for here, I'm just going to give you, this let's say is, this length is let's say A, or I'm just going to call it K units, okay? From here up till this is K units. First, start setting up the axis. This is a revolute, prismatic, right? So this is an RPP manipulator.
Professor, post RT2 or?
Thank you. So in this case here, this will be Z naught, right? This is perpendicular to the axis of rotation, that is Z naught. How about here, D2? How will you draw Z1 in this case?
The same.
Same direction, because this is the motion. You can either draw it in downward or upward, it does not matter, but let's take it like this. This will be Z. Okay. All right. Now we are moving in this direction. This is the axis of translation for the prismatic joint here. So along the, so from here. Okay, this is a 3 degree of freedom manipulator. The previous one was a 2 degree of freedom manipulator. All right, so we need one more frame here, and we'll complete the frame once this is done. Okay, now let's set up the x-axis. Start setting up, let's find the origins first. So in this case, these two are collinear, right? So Z, this is Z1 and Z0. These two are collinear. If you look at Z0 and Z1, they are collinear. So I can choose my origin wherever I like, basically along this line. So let's say that I decide to use origin here. O1. Okay? That is the origin O1. How about here? Do I have a choice of origin or no?
Yes.
What? There is only, you cannot, in this case, I can choose the origin anywhere along the line, right? In this case, it has to be at the point of intersection of these two. These two are intersecting, so my origin has to be here.
Yeah.
Okay? Okay. Now, I need to select an x-axis. So here, because these two are collinear like this, I can choose an x-axis either like this, x1, x1, any way I like. What I'll try to do is choose, when you have an option, choose it parallelly to the previous axis so the angle becomes, we don't have to obsess about the angle. So in this case, what I'll do is I'll choose exactly parallel to this as x1. All right. Now let's go here. These two are perpendicular, right? So this is Z2. Z1 is upwards like this. This is Z1. Now I can have x1 either like this, x2 like this or like this. Right? So what I'll do is I'll take x2 like so.
Okay.
Is that clear or no? No?
One more time.
One more time, okay. So, remember the two rules for x. X has to be perpendicular to both x1 and x2, and it has to intersect the previous z-axis. I'm sorry, z1 and z2, it has to be perpendicular to. So let's draw Z2, this is Z2, and this is Z1. Okay. Now, X has to be perpendicular to both of them. This is in the plane of the board. So if I have to draw a perpendicular axis, it will be either outside the board or within the board. So I have two options for X2. This can be X2 or this can be X2, right? Those are the only two options, because if I have this as Z1, Z2, I can have X perpendicular to it in this direction or in the opposite direction, okay?
So why we didn't have the same thing for x1?
Why we didn't have the same thing? X1 is perpendicular, so these two, it is perpendicular like this,
Ah, okay.
right? It's perpendicular outside the board. It is perpendicular, okay? So always it has to be DH1 and DH2 have to be satisfied, right? These two are to be satisfied. If these are not satisfied, then our table is wrong. Okay, so the last thing we are left with is reconstructing the last axis, which will draw exactly like this, Z3 and X2. Okay, this is O3. This is the end effector frame. So now we have 4 frames, O0, O1, O2, O3. So for an n degree of manipulator, as I mentioned, you'll have n plus 1 frames. So now you can write the table. Okay, so in this case, obviously, θ1 is variable, D2 is variable, and D3 is variable. All right, find the other parameters. Write down the other parameters.
K.
Hmm?
K.
Write down the other values. I'll give you a few minutes and then we'll do it to check if it's correct or not. I'm going to give you a handout once we finish a full example with the transform, so the steps will be clearly outlined. But for this example, just follow the previous one that we did and try to set up a alpha d theta.
The one big K.
Huh? I don't know, you told me. So remember that this is distance along xi. This is distance along zi minus 1. Okay. Alpha is the angle between zi minus 1 and zi. Theta is the angle between xi minus 1 and xi. Okay. These are angles. one last minute, try to do at least two rows, and then move. So you know exactly if what you understand is right or wrong. Unless you do it, you will not know whether what you're thinking is correct or not. At least do one or two tables, so we can clear up any confusion you might have.
Should we know the distance between O1 and O2?
Okay, sometimes it's not given, but if you think you should know, assume some, write down and assume it, okay? Because we're not talking in terms of finite units, we're just representing using variables. So assume anything that is,
Okay.
you think is needed. Really good. All right. Okay. So A is the distance along xi, right? Just as we did here, A was along the distance along xi. So in this case, if I want to find A1, it is distance along the x1 axis. So distance along x1 till it is intersected by the z-axis, right? So if you're trying to measure distance along x1 till it is intersected by z, z is intersecting it right at the origin. So x1 will be, I'm sorry, A1 will be
0?
0, all right? Because A is the distance along x-axis. So it is intersected by z at the origin, right?
Yeah.
So you're not measuring any distance along x. Okay. Let's do the same thing here. x2. A2 is distance along x2 till it is intersected by z1. Again, z1 is intersecting here. So x2 will also be, I'm sorry, A2 will also be 0. Same thing here, because x3, if you want to measure distance along x3, z3 is intersecting exactly at the origin. So this is also going to be equal to. All right. Let's do D first, okay, and then we'll come to the angles. D is the distance along zi minus 1. So if I want to find out D1, I have to measure along Z0.
Z0.
So distance along Z0, you go up from here, distance along Z0 till it is intersecting x1. So this is K. So this will be K. Okay. These two are variable, so they will depend upon the instantaneous displacement. So these two will keep on changing as you are increasing and decreasing for them. So that is done. Is that clear? In this case, we are measuring along x. Here you are measuring along Z0. So that's why you have K here. Okay. Now let's look at alpha. Alpha is the angle between the two z-axes, right? So tell me what is alpha 1? 0, because these two are parallel and they are collinear, measured along x1. So this will be 0. How about alpha 2?
Pi by 2.
Pi by 2? Okay, let's see if it's pi by 2. So here you have z2. And Z1 is like this, right? This is Z1. Okay. If I redraw this, it's going to look like this. Z2, Z1, because Z1 goes up like this. And this is X2. So you're measuring the angle like this, but the angle is measured, alpha is the angle from Zi minus 1 to Zi. So it is the opposite direction, right? So this is going to be negative 90, because the positive direction is like this along the axis. This is the axis. So when I go about the axis, I'm actually going from Z2 to Z1. So you can write it as 270 or minus pi by 2. Okay? The next alpha is obviously 0 because these two are parallel. So that is nothing special. So this will be 0. Okay? Let's do theta 2. How about theta 2? How about theta 2? Theta 2 will be the angle between
0.
Theta 2, if you want to do theta 2 will be measured along Z1, the angle between x2 and x1. So in this case, these two are parallel, so this will be 0. Then you want to measure theta 3, which is the angle between these two. X2 and x3 are again parallel, so this one will also be. Okay.
I don't get it. How you get a D?
How did I get this one? This one. Okay. Okay, so when you measure A, you're measuring along xi, right? So if I want to measure A, I'll measure along x1. A1 is along x1, right? So x1 here, it is intersecting at exactly at the origin O1. So x is 0, right? The distance along this is 0, so this is 0, right? The next distance is D, okay? So if I want to measure D1, I have to measure along Zi minus 1, so that is measure along Z0, okay? So Z0 starts from O0, right? So you measure from here up till it intersects to the next one, okay, O1. So this distance here is given as K, all right? So this will be measured along, this distance is measured along Z0. This distance is measured along Z1. This distance is measured along Z2.
So for the second D and the third D, they should be D2 plus the length of the link, right?
Why should it be plus the length of the link?
Because
D2 is measured from here, from this origin, right? From this origin, so this displacement is D2. Okay? So if this becomes 0, this will coincide here. Or it will go up, because this is a prismatic joint. Okay? So this distance, actually when I draw it like this, it means this whole distance is variable. Right? So when this compresses, this will exactly overlap onto this. Okay? When I say D2 like D3 like this, that means this whole distance is variable. Alright? So this will be D3. So when D3 is 0, this origin will come and overlap with O2. Okay? If these two are 0, all three will come here. Alright?
Producer, in this case, we suppose x to the outside of the board, right?
Yes.
If you suppose x to inside the board, then theta 2 will be 180 degree.
If x2 is inside the board, okay. If x2 is inside the board, this is what it will be. Right? So you're doing it like this, right? Because these two are perpendicular. You're changing x2. You're not changing the alignment of these two. So this will be plus 90 degrees.
No, theta 2
Theta 2.
will be 180 degree.
Where is theta 2? Theta 2 is this.
Yeah.
Theta 2 will be, okay, all right. So x2 is like this. Let me draw it. This is x2 in that case, and x3 is going to be like this, right? And you measure theta along Zi minus 1. Zi minus 1 is Z2, right? So you measure along Z2 like this, so the angle from here to here. All right?
Professor, why you are ignoring y-axis?
Okay, good. So that is one of the drawbacks of this notation, is that you cannot measure any displacement or any rotation about the y-axis. Now, when you look at this, you have two displacements and two rotations, right? So when I construct a homogeneous transform with this, what I'll do is, I'll set it up as a set of transformations. So I'll write translate along x, rotate, and then another rotation and another translation. Okay, so Z, X, Z, and so on, depending upon how I want to order the 4. Okay, but if I add Y, then it becomes 6. A rotation about Y and a rotation about Z. So the idea is to have the minimal number of parameters by which I can define a link transformation. So the minimum number of parameters you need is 4. One of the drawbacks obviously is that you cannot visualize a rotation that is, let's say, along, there is no representation of a y-axis. You can have a y-axis, but it's a dummy axis. You don't measure anything along y. Okay? So you can complete the frame. For example, if I want to complete the frame here, in this case, this is my thumb and the index finger. So y will be outside the board. This will be the direction of y. I can complete the frame wherever I need. This is x, y, and then this will be y2. Okay, you will complete the frame, but you're not doing any measurements along y-axis. So y-axis, that is one of the drawbacks, that you cannot do any rotation. So if you come across a manipulator where you have an axis which has a rotation or transformation along the y, you'll have to rearrange the axis and make it along x or z so that you can measure it. Okay.
I'm sorry, Professor. What? Where would x be for a to have a value in this particular question?
Where would x be for a to have a value?
Yes, instead of a being 0.
Instead of a being, so as I explained to you in the previous case, if you want to have both, let's say a and d at the same time, right? So let's say that you had a case where we had a link like this, right? This was the first method. Instead of this, if I have a link like this, you measure, this is measured as a, because this is the distance along x1, okay? Sometimes you'll have a link which is like this. Okay, so you measure, this will be d along z0, this will be d1, okay? Because these are perpendicular axes, right? So this will be the link length, this will be the link offset, okay? In this case, what you do is you'll actually have to move the origin. We'll discuss that. That is a little specialized problem, but we'll do that once we get to understanding how to do this. Okay, so I'll give you one more question. Actually, SCARA will have one link which also has A and D at the same time. So if I want to have let's say I want to have x at the value of A1 at the same time, then what will happen is there has to be a distance like this. So the link will be like this. This is measuring along the x-axis. So this will be A1, this will be A1. All right? This will be offset. So when you rotate, it will rotate like having an offset here. All right? So this will be, if I have it like this link will rotate like this, instead of being like this. In this case, it's straight like this. But if I have an offset, a joint displacement will be like this. Okay? So this, I'm measuring one distance along this. Something has to be measured along this axis, right? In which case, if I move this here, D becomes 0, A becomes 0. If I move this far away, A starts appearing, all right?
So the A1 is, we said, instead of 0, we need to put A1, right?
Here, here.
Here, okay.
In case there is a displacement.
Well, we are thinking it's rotating.
No, if you have, not in this case, but in this case.
In this case,
Yeah.
yes. Okay.
So we'll do, when we go to a SCARA manipulator, and I'll give you other examples where you'll find it difficult to do it without having a displacement compensated for. Okay, let's see if we have time. Okay, I'm just going to give you, or at least let's get started with one. Let's try to do a SCARA where you actually have a D so that we can. Okay, I want you to try this example and see what you arrive at. Okay, this probably does not have a D, but anyways, let me give you this so that everybody is. this is theta 1. Let me give you the reference axis. Let's say this is x. Actually, let me call this as x. Okay. Now here, this is theta 2. Okay, I'm going to call this distance as k, k1, let's call this as k1, and this distance as q2. Let's at least try to set up the axis before we leave so you can fill in the table. Now again, if you come up with a different set of axes, it's not a problem so long as, always check if you're satisfying these two rows at every selection of x. If these two are not satisfied, it's wrong. So long as these are satisfied and you come up with a different set of axes, it's perfectly fine because you always have a choice of selecting x or the origin. So what I draw is not the only answer. Obviously, you can have a different set of axes, but eventually we should end up with the same transformation. The only way to ensure that we come up with the same transformation is dh1 and dh2. dh1 is xi is perpendicular to zi minus 1, and xi intersects zi minus 1 and 0. These two have to be satisfied at all times. Okay, so here, because this is a revolute joint, this will be 0.